Welcome everyone to Unit 6, our final unit. We'll start off with Lesson 1, Perimeter and Area, which is a topic that everybody should be familiar with. It's definitely something that you have done in multiple years in elementary school. Some of this unit is going to be review of that. There will be some new things, but most of it, which is great, most of it will be a review of what you really learned in all the years in elementary school when it came to geometry. So our unit is 2D and 3D geometry. As such, we're going to be using a lot of the 2D and 3D geometry formulas. And if you look at the start of your packages that you downloaded from my website, you will see that there are two formula pages right at the start of that package. And so for this first lesson called Perimeter and Area, we're going to be dealing with this first page. So the formula is found on this first page. But as we progress through the unit, we're going to move on to the 3D figures, which would require using these formulas. All right, so I'm going to be constantly referencing this page, so I'll be swiping up here and constantly referencing the formulas on these pages as we do examples. Okay, the great thing is about this unit is that it's really just looking at the question and finding the right formula to use. Okay, knowing how to substitute your values into the formula and then solving. All right, so it's pretty straightforward, in particular this first lesson. All right, so let's just do a quick recap of what perimeter and what area is. Okay, so the perimeter is what you could think of in terms of it is a boundary of a closed shape. So it's the length of the boundary of a closed shape. So that's what I'm going to write here. The length of a boundary in a closed shape. Okay? So what does that look like? And some words that help us identify what perimeter is. So what does it look like? Well, if I were to draw a circle, it would be the boundary would be the where my pen has touched the screen. The length of that boundary, okay, would be what is called the circumference actually. So when it comes to a circle, the perimeter, there's another name for it. It's called the circumference. And that's the only special word for perimeter. In any other cases, it is known as the perimeter. But when it comes to a circle, it's known as the circumference. And the circumference is the length of that boundary that I just drew that's in a circular shape. Okay? In any other case, like if you have a rectangle, that's known as a perimeter. If you have a square, of course. Okay, if you have a square, that is known as a perimeter as well, the length around the square. Okay, we're also going to be dealing with trapezoids, okay, and triangles, of course. We're going to be finding the perimeter around all of those shapes. When it comes to word problems, all right, often you'll see the words fencing. So if you're calculating how much fence you need to enclose an area, you would be finding the perimeter. Okay, so fencing is a potential word that we might see in a word problem. If you have to calculate how much fencing you need, you know that it's a perimeter problem. Sometimes you'll see the word edging. Okay, so if you're doing a garden, you want to put what's called edging around the garden, okay, to kind of enclose your garden with something, whether it's some sort of interlock brick or just some plastic edging that you can buy at the store. All right, that's another example, a real life example of calculating perimeter. Okay, so like I said, in a word problem situation, look for keywords. If it says something about fencing or edging of some sort or anything that has to do with enclosing an area, you know that you have to find the perimeter. Okay, specifically if you're dealing with a circle, it's not called the perimeter when you're dealing with the circle, it's called the circumference. Okay, scrolling down, okay, to area. How could you define the word area? If perimeter is the length of the boundary, okay, perimeter is the length of the boundary, then how can we define area? Well, area is the measurement of the surface within a boundary. So it's the space within the boundary. Okay? So for example, okay, something that could a real life example that could represent area is if you're laying down, let's say, new grass in your backyard or in your front yard, okay, you're not dealing with perimeter anymore. If you're laying down new grass, you're dealing with the area within the perimeter, so the area inside the perimeter, and that is known as area. Okay, so that's the space inside the boundary or perimeter. All right, so if I were to draw some shapes, let's say I'll do my best there to draw a square. It would be the area inside the square, the space inside that square. All right, and that goes for any shape, whether it's a circle, trapezoid, triangle, rectangle. It's always the space inside the shape. All right, so without taking too much more time here, I'm sure this is something that we are all used to hearing or have heard before from elementary school. Maybe you just needed a quick refresh in your mind of what those two definitions or what those two terms meant. All right, and of course, when it comes to 2D shapes, we know that 2D shapes are just shapes that are flat, okay, on your paper. They do not have any heights. Okay, so it's any shape that can be drawn flat on and it looks flat on your paper is known as two-dimensional. Okay, anything that's 3D, okay, will kind of seem like it's popping out of the page a little bit. Okay, that's my kind of sad attempt at drawing a cube there. Okay, but that would be considered a 3D shape versus the 2D shapes that I drew above. So instead of a circle, now I'm not going to be able to really draw a sphere, okay, but a sphere would be a type of 3D shape, okay, and then instead of a triangle, a triangular prism would be a 3D shape, so it could look, one sec here, let me just try to draw this half decent, but it could look like this, okay, almost like a Toblerone bar almost, right? That would be a triangular prism. Okay, and then you have pyramids as well. So you have like a triangular based pyramid, a triangular pyramid or a square based pyramid, and so on and so on. All right, so let's start some examples. Let's get right to it. We're going to find the perimeter and the area for each of these shapes. Okay, I'm not going to do all of these examples here because it's going to get a little bit repetitive. So I'm going to just do probably the question A, C, and then E and G. So I'll stick to the left side of the page. All right, and that will encompass pretty much all the different shapes we need to worry about. Okay, so It says, always read the instructions, right? It says to determine the perimeter and the area of each figure. So we're going to find both, all right? And we've been given enough information here. It's up to us to find the right formula and plug in the numbers where they need to go in order to find the perimeter and area. So we know that, of course, this is a triangle. Okay, let's find the perimeter formula for a triangle. Okay, so I'm going to scroll up to my formula sheet really quick. Find my triangle. Okay, right here. Here's my perimeter formula, and then here is my area formula. I'm going to need both of those. So for perimeter, it is A plus B plus C. So the length of all three sides, the three boundaries inside the triangle or of the triangle, that will, if I add those together, I will get my perimeter. And then my area is the base of the triangle, which is right here, times the height, which is right there. So how tall the triangle is. And then divided by 2. All right, so I'm going to write those out, and then we are going to solve that question. Okay, so pretty straightforward. Okay, so P equals A plus B plus C, and that was just A plus B plus C is just the length of each side. All right, so let's just solve that right here instead of just writing the formula. So let's find, and notice how I line up my equal signs. Let's call, and it doesn't matter what you call A, B, or C. Actually, let me just put my B there and my C there, okay? But it doesn't matter in this case because we're just adding them together. So it's 2.1 plus 3.5 plus 2.5. Now you may ask me, how do we know how many decimal places to keep, right? Well, always look in your question. If you see that there's one decimal place being used in all of the given information in your question, usually the rule of thumb in math is to also use one decimal place. Unless the instructions, the question itself, say to use more or less, usually the rule of thumb is that you just use the amount of decimal places that are given in the question. So add these up and your final answer is 8.1. Now don't forget your units. We're using meters here. So it's meters. Put a box when you have found that. All right. Next, we are going to find our area. So it's area equals base times height divided by 2. All right, let's look at my triangle. Where is the base of my triangle? It is the 3.5. That's the base. That's kind of like the bottom of the triangle, I guess. And what is my height? Okay, my height is here, 1.5. This is my height right there. So I'm going to have base is 3.5, height is 1.5. And all I'm going to do is sub them into this equation. So B, instead of B, I'm going to put 3.5. Put it in brackets because we're going to be multiplying the base times the height. The height was 1.5, and then divide by 2. Again, since the question has one decimal place in all that was given to me, I am once again going to use one decimal place. So your final answer here is 2.6. Now, what are my units? For perimeter, it was just meters. But when you're finding area, because you're multiplying the numbers together, it's actually meters squared. So any area question will be the units squared. All right, so my final answer there is 2.6 meters squared. Okay? Now, the next question was a square. I'm not going to do this question, but to find the formula for a square, by the way, how do you know this is a square? You know because of these tick marks indicate that all of those sides are equal. That's how you know that's a square. And so what you would then do is just swipe up to your formula sheet, okay? And actually, there is no formula for square here, even though it would be the same as a rectangle, but let's actually write out the formula for square. So I'll do my best to draw a square here. And you can add this to your formula sheet. Okay. The perimeter is adding up all four sides, so it could either be A plus B plus C plus D. Okay, so let's say this is A, B, C, and D. Or because they're all equal, we can shorten this formula and just say that it's 4 times a side length. 4 times a side length. So just one of the lengths times 4 because they're all the same. So 4s. So how about instead of using A plus B plus C plus D, all right, I'm going to use the letter S. All right, so let's say these are all S's. They're all the same, and that's why I'm assigning the same letter to each of the side lengths, because the side lengths will always be the same. All right, so it's like saying S plus S plus S plus S, but a short form version of that is 4 times S. The area, okay, the area, it's really just length times width, but because they're both S's, so it's S times S. So S times S, which is really just S squared, as you learned from Unit 5 polynomials. A letter times the letter is that letter squared. Like x times x is x squared. S times S is S squared. All right, so these are my two formulas for perimeter and for area. Okay, let's go back and let's continue. I really want to get to this circle question because we have here something that we need to review, which I know we've done in elementary, but the difference between a radius and D for diameter. All right, what is the difference between a radius and diameter? Well, a radius, as shown in this circle here, is only the distance halfway through the circle. So this is R. Okay, it's halfway through the circle. Whereas when you're dealing with diameter, it's the entire length or distance through the circle. All right, so radius is half of diameter. So I want you to keep that in mind. Okay, so we know that, of course, this is a circle. All right, and now what are my formulas? Well, I know that for perimeter, the real word is circumference when it comes to a circle. So let's take a look at a circle up in my formula sheet. And what is the circumference? Well, it's either pi times diameter, where pi, of course, hopefully you know this as well from elementary, pi is 3.14. All right, that's what pi is. So we have the choice here to choose pi times diameter or 2 times pi times r. Which one do you think we should use? Well, I mean, since we were given the radius, it makes sense to use 2 times pi times r. Okay, 2 times pi times r because we were given the radius. So if I come here, I say that c equals 2 pi r, or 2 times pi times r. Plug in your r. Use brackets. So 2 times pi, and my r, of course, is 4.4. Again, 1 decimal place is being used there. Just You may have a pi button in your calculator, but you can always just use the number 3.14 for pi, right? So pi equals 3.14. Okay, your final answer there is 27.6. Again, we're dealing with meters, but because it's the perimeter or the circumference, just leave it as meters. Now the area, okay, you would check your formula sheet for the area. I know that the area of a circle is pi times r squared. Okay, now remember r squared really just means r times r. And my r I know is 4.4. So I have pi times 4.4. Okay, I hope you know where your exponent button is on your calculator. If you don't, just do 4.4 times another 4.4. It means the same thing as 4.4 squared. Remember to follow BEDMAS here. We can't multiply until we do our exponent, right? Following BEDMAS. Sorry about that. Following BEDMAS, I know that I have to take care of exponents before I can multiply. So I have to do 4.4 squared first. So what is 4.4 times 4.4? It is 19.36. Now I can multiply it by 3.14. Okay, and you should get to 1 decimal place. Notice how here I have 2 decimal places. Because within the question, I want to maintain accuracy. So I keep as many decimal places as possible. But in my final answer, I only give 1 decimal place because that is all that is given to me in the question where it gave me the 4.4. That only has 1 decimal place. So my final answer I can show as 1 decimal place as 60.8 meters. And that's right, squared. Okay, when you're dealing with area, don't forget to square your units. Okay, so that's if you're dealing with radius. If you notice, this circle deals with diameter, and that's okay. There's a separate set of formulas, okay, where you can use pi times diameter instead of. Sorry about that again. You can use pi times diameter instead of 2 times pi times r. Sorry about that. Okay, now when you look at area, you can see that for the area, there's only the radius. There's no formula for the diameter. And that's okay, all right? So don't worry about that. Here's what you do when you get that situation. If I know I do this all the time. If I'm given the diameter, I right away take this and I divide it by 2 to give me the radius. Okay, so 8.5 divided by 2. I end up just using 4.25 as my r. And then now that allows me to use the formulas that are given to me, like circumference equals 2 pi r, or area equals pi r squared. So if you're given diameter, do yourself a favor, just divide it by 2 so that you can turn it into the radius. Okay? All right, let's do a parallelogram and then a trapezoid, and that is it. Okay, so a parallelogram, let's find the formula that I can use for that. So let me swipe up here. Okay, here is our parallelogram. Okay, right there. The formula is just for perimeter, just adding up all the sides. So this side is equal to this side, so that's another B. So we have B top and bottom, and we have C left and right. So if I just add up all of those side lengths, I will get the perimeter. All right, a short form version of this is to use this, but you know what, let's stay consistent and let's just add up all the sides. I mean, that's when you're finding perimeter, that's all you're doing. Okay? And then the area is going to be base of your parallelogram times height of your parallelogram. All right? So let's go back and let's just add up all four sides. So this is a parallelogram. And the perimeter, if this is side B, this is side B as well because they're equal. This is C, this is C. So it'd be B plus C plus C. You don't really have to write that formula out because it's so basic. I mean, you can just get right into adding up the numbers. So it's 8 plus another 8 here. It's not shown there, but we know that in a parallelogram, it's basically just a rectangle skewed over to one side. And in a rectangle, we know that the top and bottom sides are always equal and the left and right sides are always equal. So we have 8 plus 8 plus 5 plus 5, which is 26. Look at your units, centimeters. Okay? Now let's scroll down. Okay? And I said earlier that the area, and let's put a box around that. The area was base times height. Okay, so let's look at my diagram. I have my base is 8. And what is my height? Right there, which is 3. So we have 8 times 3, which is 24. It's still centimeters, but it is centimeters squared when dealing with area. Okay, so that was easy. So now our next question, okay, is maybe one of the more difficult shapes, but it's still easy. We still just continue to use the formula for it, so I wouldn't worry too much about it, okay? The perimeter is still very basic to find. You just add up all the side lengths. And of course, when I say add up all the side lengths, I do not mean the height. You do not, when you're dealing with perimeter, you're only doing the outside boundaries. You're adding up the outside boundaries, not the height there. Okay, that height is irrelevant. It's only helpful to find the area, but not to find the perimeter. All right, so shape, this is a trapezoid. Formula, I'm not even going to look up at the formula sheet. I already know that I need to add up all the sides. All right, so I already know that I need to do that. So I'm just going to add them all up. It's 9 plus 5.4 plus 14 plus 4.9. Okay, so pull out your calculator and you have 9 plus 5 plus 5.4 plus 14 plus 4.9. Okay, so your total there, if you were to add that up, is 33.3. And again, use one decimal place because throughout this question, we were given one decimal place. And put your units, 33.3. Now let's find the area. The area is going to be a little bit, the formula is a little bit trickier. So let's look at the formula for a trapezoid. Just scroll up. Here it is here. Okay. It is A plus B, add them together, and then multiply them by h, or the height, and divide them by 2. So let's look. We're going to take A, we're going to add B to it, and then we're going to multiply it by h. All right, so C and D are totally irrelevant here when it comes to finding area. All we need to know is A plus B, and then multiply it by h and divide it by 2. Notice that a plus b is in brackets, so you have to do that first before you multiply by h. Okay, so let's go down and let's finish this off. All right. So we have a plus b in brackets, multiply it by h, and then divide it by 2. Well, let's look at what my a and b is here. Let's call this b, and let's call this a. All right, so it's your base and then the top. So we have 14 plus 9. Times h. What is my h? Let's go back here. It is 4.5. That's my height. Okay, so then simply do 14 plus 9, put another brackets, put another set of brackets, and put your 4.5. Okay, and then the formula did say, don't forget to do this, it did say to divide by 2. So it's a plus b times h divided by 2. Now let's follow BEDMAS. What is a plus b? Okay, 14 plus 9 is 23. Keep that in a set of brackets. Now take your 23 and we're going to multiply it by 4.5 and then divide it by 2. So on your calculator, you would press 23 times 4.5, hit the equal sign, okay? Then press divided by 2. All right, and so I'm just going to put what it equals here. Area equals, and again, I'm going to do 1 decimal place. And actually, this brings up a great point. You end up getting 51.75. And now the question is, when you get 51.75, should you round up or down? Should you go to 51.8? Or should you do 51.7? Okay. The answer to that is whenever you have a 5, like you have here, you always round up. If you're doing to 1 decimal place here, it would end up being 51.8. And that is in centimeters. And again, square. And there it is. You end up getting 51.8 centimeters squared. All right. I think that concludes my note for this lesson. All right. This is pretty straightforward, stuff that you've done before. Make sure you choose the right formula. Okay. Make sure that you plug in the numbers in the right spot in the formula. Okay. And lastly, all right, make sure you follow BEDMAS rules when you are solving that formula. All right, so 3 things to remember. Pick the right formula once you identify the shape. Plug in the numbers correctly into their right spots. And then lastly, okay, make sure that you follow BEDMAS rules. All right, if you do all those things, the only thing you can really do wrong is maybe a little calculation error in your calculator. Maybe you press the wrong button or something along those lines. But beyond that, you should be